Welcome to Coffee Break. I'm your host, Dana Curtis, and this is episode 1 of season 15. Here at Coffee Break, we invite you to join us as we dive into the fascinating world of all things microchip technology and about the time it takes to enjoy a fresh cup of coffee. For those of you joining us for the first time, Coffee Break is a live broadcast, so let's take it over to Aaliyah Fahut for some housekeeping items. Aaliyah, what do you got for us?
Hello, everybody. Thank you for tuning in today. We are broadcasting on YouTube, Facebook, and LinkedIn. And we invite you to participate in today's episode by leaving your questions and comments in the chat, or you can email us at livestream@microchip.com after this broadcast. If you're watching us on YouTube today, make sure to subscribe to our channel and click the bell so you know when we're live and when our next episode is. If you're watching us on LinkedIn, make sure to subscribe to the event so you can get all the information related to this episode. Back to you, Dana.
Thanks, Aaliyah. Today we have a very special guest joining us. Amit Goel is a product marketing manager here at Microchip Technology, returning to Coffee Break to talk to us about the new family of IGBT7 devices. And we're going to talk specifically about power, performance, and precision. Welcome back, Amit. Let's start with the obvious question.
Thanks, Jenna.
What is an IGBT and why do we need a 7th generation of them?
Well, let's start with the introduction of IGBT from its full form. So IGBT means insulated gate bipolar transistor. It is a 3-pin power device. You've got collector, emitter, and a gate. And it's a voltage control device. So by virtue of giving plus 15, minus 5, or plus 15, 0 gate voltage, you can control the power. And because of its simplicity, it is called a powerhouse of entire power semiconductors market. Across all applications, including but not limited to motor drive, sustainability, megatrends, as well as aviation. So it covers all gamut of applications. And when we talk about modules, so modules has got the IGBT chip, and across it, it has got anti-parallel diode, and a number of combination of this are placed on the copper base plate to make a module, so that's about IGBTs in general, and IGBTs had many generations in last multiple decades. IGBT 2, 3, 4, and what we are talking about here is IGBT7, which provides lots of distinct advantages over its predecessor.
Now, you touched on a couple of the earlier markets, but I see here we've got a whole wide variety of different markets here, from motor control to e-mobility to transportation. IGBT applies to all of these?
Yes, so most of this application, they fall into low to mid switching frequency, which means about 1 to 2 kilohertz for very high power motor drives, to up till 15, 20 kilohertz for UPSs. And IGBTs, because of its ruggedness, its low VCSAT, and very good short circuit capabilities, are famous across all these applications, and can be used without any issues because they are very simple to drive. Their availability is pretty good, and people are designer engineers across the field. They're pretty much used to it, how to do the control schemes and power schemes for IGBTs. And because of these reasons, they are pretty much commonplace. But, designer engineers always are looking for the next best thing. And that's where IGBT7 comes in picture, which would serve all these applications and megatrends.
Right. So what makes Generation 7 unique?
Well, there are a number of reasons Generation 7 is unique. There are a few aspects of it. They are related with its features, such as higher overload temperature, 175 degrees Celsius, lower VCSAT, that is lower power loss. It is very easy to drive. It has got power size jump capability, that is 50% more current. But if you look at the overall market of power modules, IGBTs command this entire market by around 60% as we speak. And if you apply a normal CAGR of just 7 to 7.5%, the market would still be sizable, around 50%. So the low to mid switching frequency zone is pretty much covered by IGBT7 products. When it comes to very high switching frequency, other technologies such as silicon carbide or GaN could be used. And all these, succinct features of IGBT7 that I mentioned, such as high current capabilities, higher junction overload temperature, easiness to drive the module, as well as lower VCSAT, which results in lower power loss. They give, in general, compactness, higher power density, and higher efficiency. And those are the reasons IGBTs are famous in this application. And IGBT7 will give a step increase in a utility across all these applications and megatrends.
Great. I know that everybody seems to have an IGBT variation. Of course, we're not the only player in the game, but what makes us unique? Why Microchip?
So we have introduced IGBT 2, 3, 4, 5 for fast before. So this is not the only series that we have. We already have, all the rest of the series, and now we're introducing IGBT7. And the distinct advantage with Microchip is we don't only provide the standard packages, but we also provide the Microchip low inductance, low profile packages. So what do you mean by this? So as you can see, D3, D4, they are standard 62 millimeter packages. So these are very famous packages. So they are 62 millimeter because of its depth. They are 62 by 108, and these are in use for almost 2-3 decades. Very commonplace packages. So we can provide these packages. Now the issue with this package is that it has got high inductance, around 20 to 30. Some of the players they got 30. Our inductance is 20. Now what we provide is lots of other different packages such as SP6C, SP6P, SP6Li, which are smaller. They are 62 millimeters, so they can fit the scale. Mm-hmm. They are almost same. So it's not designer engineer don't need to do many things related with the footprint. Footprints are exact same, but if you look at the height, they are 17 millimeters, so they almost are smaller.
Yeah.
But the key thing is that the inductance of these packages is predominantly low, and because of the lower inductance, the overshoot is less, and because of that overshoot, there are lots of advantages that you get. The biggest one of that is the reliability, because your overshoot is less, your overall application lifetime, you have better durability and reliability. And this is our package, which has got the lowest inductance. It's SP6Li. Now you can compare with the standard package. It is pretty sleek, and it can handle higher power. And because of its low inductance, which is less than 3 nanohenry, 2.9 nanohenry to be precise, the overshoot is less. So if our competitors give D3, D4 package, we can also give those. So when people use those packages for 650 volt DC link, they would use 1200 volt. But as we go beyond that point, with those packages, because of higher overshoot, the designer would use 1700 volt device. Now, if they use SP6Li, Microchip SP6Li, for those current ratings and those voltage ratings, there are higher probability that, with a better layout, I mean, we have got low inductance, but customer also need to have better layout. They can obviate the need to use 1.7 kV device, which would mean almost 30% cost saving per module, and almost 10 to 20% cost saving per driver. So if you combine this, because there are lots of modules and drivers in the application, it gives a huge competitive advantage for our end customer in terms of packing the same power with the same power density with lesser cost.
So cost savings alone would be a reason, but are there any other reasons that a designer might want to upgrade their design from, say, 4 or 5 generation to IGBT7?
Well, there are a number of them, and I would like to highlight three key aspects. Mm-hmm. So IGBT7 current capability is almost 50% more. So that means previously for example, the single switch in this packages would be 600 ampere. We can give 900 ampere, so that is 50% more. So when you pack, almost 50% more power, what it does, invariably depending on your loss calculation and other factors, your power density becomes very good. So the compactness is really good. And with that, you don't need to parallel number of modules. So for example, without that 50% increase, you would need to parallel number of modules to achieve the power levels. Here you can use a single 900 ampere, and because you are obviating lots of bulk, your design becomes compact. And that also adds to overall cost efficiency, because you're not paralleling number of modules. There's a lesser complexity in terms of driving. You just got one single module. So that's key advantage, and that enhances the overall power and performance. The second one is power losses. Now for IGBTs, there are two components of power losses. One is conduction, another is switching. Now, in conduction, the losses are governed by VCSAT. And if you look at the comparison between IGBT4 and 7, IGBT7 offers almost about 20% lesser VCSAT, which results into 15 to 20% losses depending on which module you are using. So when you talk about efficiency is basically the power loss within the converter, which is output power divided by input power, and whatever the difference between output and input power is a loss of the converter or inverter that you use. So with lesser losses, your efficiency goes up. So this would really help our end user to not only pack more power, but to have really good efficiencies, and with efficiencies come cost savings. The third advantage is it's pretty unique. So most of the generations up till IGBT4, they had the junction temperature of 150. Now, some of them might have had 175, but invariably most of them had 150. Now, this particular generation, so these devices, they have junction temperature at overload rated 175. Now, this is a huge leap. Why? Because the key applications such as motor, UPSs, railways, they have this short-term overload, and they're application dependent. So you're using bottling plant, you're having motor drive, you're having UPSs. So they have this intermittent load, which are less than 60 seconds, and depending on the load, they're 110% of the rated or 150% of the rated load capacity. So what happens during those duration, if you use the previous generation, because of you're limited by 150 degrees Celsius, you have to use higher power module. But here, because the rated overload is 175, 25 degrees Celsius, bigger than 150, and that gives you a tremendous advantage for those overload conditions. So you don't need to over-design your product, over-design your power system, and it gives tremendous, what we call a cost-to-performance ratio, because within the same unit, you can basically take care of the overload as well. And for motor drive, for UPS, it is great news.
Lots of flexibility, yeah. What about precision?
So precision. So when we mean by precision is ability to seamlessly control the motor drive application. So most of these IGBT modules would go for motor drive. Now the applications at higher level would look different. So there could be railways, there could be bottling plants, there could be a general purpose motor drive, but at the core of it is the induction motor. So in a bigger plants, you have the induction motor, and then you have induction motor drive. So drive has got the converter, which is consisting of IGBT power modules, and the drive runs the motor, and in between there's a big cable. Now, because of the switching, now generally motor, they are not switched at very high switching frequency. It is kind of limited depending on the nature, 1 to 8 at the max. Generally 1 to 4, it's a sweet zone. But still, because of those rise and fall times, there's a voltage overshoot, which writes on the output voltage, and because of that cable, the matter becomes worse at the motor terminal, and those voltages could be double that of DC link and could actually burn the insulation. Now there are certain standards that exist in a motor control world, which specifies what should be the dV by dt at the motor terminal and at the inverter terminal. So for designer, they really need to know how they can achieve that precision. Now with IGBT7, depending on the request, we can give you a chart of what would be the dV by dt depending on the gate resistor that you use. So we use gate turn on and off resistor. So we specify this. So by optimizing that gate resistor, you can change the dV by dt. So that range is around 2 to 8, 2 to 8, and 5 is kind of median, which you're looking at in the picture. And so designer just don't need to worry about that. They can look at those characteristics and accordingly make sure they are having the desired dV by dt, and that would help for for overall application, for motor drive application. And it is with precision and with lots of ease.
Great. So where can viewers learn more if they're interested in more information about IGBT7 and what our product portfolio provides?
Well, we got our IGBT landing page. Mm-hmm. You can refer to that here. You can refer to the QR code. There we have got lots of information. So again, this is IGBT7 gen that we are introducing, but we also have IGBT 2, 3, 4, the previous generations, which are still in the market. And with this IGBT7, we give power, precision, and performance all the way up till 900 ampere, 1700 volt in single package, across 7 packages, 49 parts that we have introduced. And with this, you can support a number of applications and megatrends without any issue. And we also have excellent application support. Mm-hmm. And if any customer needs to tweak certain things, if they want anything which is non-standard, we can give customized solution. And we are very unique in the market, one of the very few companies that can actually build the power module or total solution depending on customer requirements. So not just standard, but we can also give custom solutions
as needed. Great. With that, let's get over to Aaliyah to see what kinds of questions we have from our audience. Aaliyah?
Awesome. Let's start with your first question, Amit. The first one is, what do you say about IGBT7 adoption?
Well, IGBTs are pretty sticky in all the generation in that because of their ruggedness, generally the transition is pretty slow. But with regard to IGBT7, because of those distinct advantages, the adoption is pretty fast. As we speak, around 25 to 30% of the entire power module market has adopted IGBT7, and while the remaining market is with the legacy technology. So adoption is pretty fast, and it will go hand in hand with the need for the customer to have better power density and better efficiency.
Awesome, thank you. Second question for you, why are IGBTs so prevalent in motor drive?
Well, motor drive is very commonplace application, and what user expect is ruggedness, reliability. So IGBT gives that because of its very high short circuit capability. And these applications, they fall in relatively low to mid switching frequency application where IGBTs are pretty economical, and they also provide lower loss, better efficiency. And another reason is that availability. So you don't need to worry about the availability. The easiness to have the gate drive for IGBTs is one of the reasons they are very popular. And for motor drive applications, you would need the functionality to last over the period of years. And IGBTs are very good in terms of that durability, that is product life.
Thank you. Next question, let's see. Regarding railways, where are IGBTs used in railways, and where will your IGBT7 portfolio be used?
Railways, basically, there are 3 or 4 avenues where IGBT could be used. The first and foremost, which is known to everyone, is the traction drive. So whether it's electric or diesel electric locomotive, the traction drive runs the traction motor, which runs the locomotive, and their IGBTs are used. High power IGBTs are used between 3.3 to 6.5. So the highest rated is 6.5. Now we are not, talking about that in our IGBT7. So where our IGBT7 would be mostly used would be other 2 or 3 applications. So the most popular of them is auxiliary power supply, which is housed inside the locomotive. So the DC link is around 600 to 800, so you can easily use 1200 or 1700 volt IGBTs from our IGBT7 portfolio. The other application is it's called the undercarriage or underslung AC inverter. So this is quite prevalent in Europe and countries like India, where you have the passenger trains. So passenger trains, they form a big network. And for providing the air conditioning, every coach has got a 30 to 45 kVA converter, which is underneath the carriage. They could be overboard, they could be underneath. And the most prevalent rating of IGBTs used there, they are around 400 to 600 ampere and 1200, 1700 amperes. Very famous application for IGBTs. And our IGBT7 could directly fit, and it gives lots of advantages for end user in railways. And the third one would be the hotel load inverter. So this is called hotel load because it takes the, combines all the load of all the bogies and is housed in the main locomotive. So our products could also be used. So these are not small rated. These are not like 30 or 45 kVA. They could be like 300, 400. So there, our IGBT portfolio could be readily used. And because of, the key features, I think they can really pack that power in lesser size.
Awesome. Thank you so much. Last question for you. What are the extra precautions we need to take while driving IGBT7?
Well, dare I say none. Because the IGBTs are pretty simple to drive, unlike other complex technologies. So basically you need, a bipolar voltage drive. So plus 15, minus 5. Some people have plus 15, 0. So basically you need a simple voltage drive, and that's it. That takes care of your control part of, or driving part of IGBT, and you need to have VCSAT protection in your driver. So basically very simple setup, and with IGBT7, the design don't need to change. So people who are using IGBT 2, 3, 4, they don't need to change anything. They can just use IGBT7 simply because there's no complication there. It's pretty easy.
All right. Thank you so much for answering our question, Amit. And for the audience, if you have additional questions or comments, please email us at livestream@microchip.com. And don't forget to follow us on LinkedIn and subscribe to our YouTube channel. Back to you, Dana.
Thanks, Leah. That's all the time we have for today. Special thanks to Amit for sharing his knowledge and passion with us today. If you'd like more Coffee Break, head over to microchip.com/coffee break. Click on the subscribe button to get updates for all things Coffee Break. You can also see upcoming episodes for Season 15. And of course, be sure to join us next time on Coffee Break as we explore optimizing your data management with AdaptTech MaxView storage managers. Until then, stay curious, stay creative, stay caffeinated.